This is the last video on linked list that I'm going to be doing, at least as part of the lectures on linked list. And this one is in particular going to talk about some stuff that the book does a fair job of. So I'm going to highlight and annotate kind of what the book is doing rather than create new material. So in the previous videos, we talked about linked lists, what they are, how to reason about linked lists. We've gone through creating a basic one type linked list, just integers, a linked list of integers. And we talked about how to add to the front, add to the back, how to um, delete from the list, how to search through the list, those basic ideas. Okay. So the next logical development in linked list, first of all, is creating a templated linked list. A linked list that can take any kind of data type, any one kind of data type, rather than just integers. So you can have integers or doubles or whatever. Okay. And then if you're going to do that, I think it makes sense, as the book describes it, to go ahead and create. There are two basic types of linked lists that we're going to worry about, and we can reason about how that would work. We have unordered linked lists and ordered linked lists. Okay. So an unordered linked list is what we've been doing so far. You're just going to add things to the list in whatever order they happen to occur in. Okay. But with an ordered linked list, as part of the construction or as part of the adding a new node, we're going to make sure that the list is always sorted by finding the proper place to put the node. And that's going to feel a little bit like um, the delete as far as the previous and the current pointers to find the right place and be able to insert the node in order in the list. Okay. So again, they make this an abstract data type because so much of the functionality of a linked list is going to be the same for both. So that's the abstract data type. Abstract meaning it has, pure virtual function. It means you cannot create a linked list object. We're going to specialize the linked list into the ordered and unordered, and those are concrete. You can actually make items of those types. Okay. So as they define it here, the basic operations they have on the linked list are to initialize it, to see whether it's empty or not. They're doing a function for that. Print it, find the length of the list. I'm not sure necessarily how valuable the length is, but it's certainly easy enough to track, and that's what they're going to do to be able to destroy the list. Um, they've got pointers in particular for the first and the last node, and sometimes you'll see that. Okay. Especially if it's an ordered list, then you can kind of get an idea of the range by looking at the first and the last. Okay. There'll be a search, there'll be an insert, there'll be a delete, and there'll be how to make a copy of the list, a deep copy, not a shallow copy. Okay. So that's kind of how that works. They're still using the basic struct here with the info and link, but this time they're using the class type. Again, type is just a variable name that we're going to use here in order to have the type as a variable. So it could be an int, it could be a double, whatever. Okay. It could be a type that you create as an object of a class. That would be fine too. So then we have type info instead of int info. And then we have the node type sub bracket type. Okay. Because you don't know going in what it's going to be. That's your node type pointer called link. It goes to the next node. Okay. So then it talks about the member variables of this class we're creating. So there's a count, how many items are in the list, and then we've got a pointer to the first node and a pointer to the last node. That's all we're going to do. The other thing that they do here that's interesting, and again, you should read this yourself and type it in so you know what's going on. It uses this iterator here. So it's an iterator class because one of the things that we're going to do through our list is go back or go through the list, okay, to iterate through the list. Okay. We want to do something on each node of the list. Okay. So we do this. So we're going to create this iterator object. Okay. And it's going to have the following bits of information. Okay. So then it shows here what that's going to look like. It then goes through and actually defines those functions for you. So again, as you're typing it in, you can just type each bit of these, test along the way, looking for typos. There could be typos you created. There could be typos in the book. Okay. Um, so now we've got that. We can go to our linked list class. Again, this is going to be an abstract. So it's got the linked list type here. The type is the kind of their clue that it's going to be a virtual function. And these are the things that we just talked about before. There's the We're going to overload the assignment operator because it contains memory data, because it has that pointer. We don't want to make shallow copies. That's what that's all about. There's initialize the list, which will give us an empty list. There's the function here. Is it an empty list? Print, length, destroy, front, which will return the first item, back. Okay. And here are the ones that are going to be different, whether or not it's an ordered or an unordered list. So these are our virtual equals 0, so our pure virtual functions for search, for insert first, insert last. Okay, note that insert first and insert last on an ordered list aren't going to make any sense because we can't really do that. We're going to insert where we insert. Okay. Uh, delete node will be different based on whether it's ordered or not. Okay. And then here's the iterator begin and end. Okay, these are just points to the beginning and the end of the link list. There's a default constructor. There's a copy constructor, and there's the destructor, which will delete all the nodes that we've created from the list. Okay. And then we have our count. We have our first and last pointers there. Okay. That are protected somewhere in between private and public. And then we have our copy list, which is a private function that will make a copy of a list. Okay. That's what this is going to look like. Okay. It's then going to go through and show you all of these functions. So here's our default constructor where when we first create a new list, okay, we're going to have count's going to be 0. Our first and last pointers are going to point to nothing. So they're null pointers. Okay. Then it goes through the other things on initializing the list, printing the list, all of that. A lot of this is stuff that we've seen before, except that it's templated, so we have the type we have to worry about. But that's really about it. Okay. It's adding some other nice features like the copy constructor, and those things. Okay. So we then have the unordered lists, which are the simpler. We're just going to add things. Either we've got insert first, insert last. Okay. Whether that's just like our insert front, insert back that we did before. Okay. And then we've got the search. On an unordered list, you just have to start at the beginning and search all the way through. There's no telling where things are going to be. Okay. And then inserting the first node, inserting the last node, all the code for that. Okay, some more examples here of how, again, they do their diagrams this way, and I tend to have mine flipped up vertically, but it's the same idea. We're looking at the pointers, we're looking at this is showing the count, the value of the count variable as we go along, and just showing us visually how to reason about these things. Okay. So the ordered linked list has a little more going on. Okay. So it's both simpler and more complicated. It's more complicated when it comes to adding. Okay. You have to search through with a previous and a current to make sure that you're adding it at the right level. So if you have an ordered list and you're adding a 10 to it, you check the first element, you say, is this element greater than 10? If it's not, you keep going until you find one that's greater than 10. The first element greater than 10, you need to insert the 10 to the left of that. So you have to use the previous to insert it into that stream. Okay. There's an insert there as well. The insert and in first and insert last, yeah, it's not really going to help us any. Okay. So we have to have these because they're functions that were mandated as pure virtual functions. So we have an obligation to create them, but we're not going to do anything special with them. Okay. The searching of the list is different. Again, it's simpler in that we know once we hit a value that exceeds what we're looking for, we know we're done because it can't be any further to the right. So if we have a list of unknown number of items, we're searching for 25. We're going along looking at values. If we hit one that's equal to 38, we know we're done. We're not going to find it, right? Because it's bigger than the number we're looking for. Okay. So it's always sorted, which can be an advantage. Again, there's more code in there. There's more explanations of that and examples on how that works. Okay. So again, the insert first and insert last, we have to have those functions. We have an obligation to do it, but we've created for this one an insert function that's just going to insert it where it goes. So both of those just call that one. Okay. Here's deleting. We have the different cases we have on deletion, like we talked about before. Okay. here's another way we can print a linked list in reverse order. Sometimes you want to do that. Okay. So it's going to explain how that goes. It's going to give you this reverse print function here. Okay. You can go through that. And then the last thing that this chapter talks about are interesting concepts that could come in handy sometimes. So it's worth thinking about. The first is a doubly linked list. Okay. So in this case, our node has more than just the link. Okay. It's going to have basically a next and a previous. Okay. So we have here the data that we're storing. Here is the pointer going backwards. Of course, on the first node, the previous doesn't point to anything. It's just a null pointer. And on the last node, the next will point to a null pointer. That's what this shows. Okay. And all the others in between, there'll be a pointer in both directions. So the next pointer from node 1 points to node 2. The previous pointer from node 2 points back to point 1. Okay. And this allows you to traverse the list in either direction. You can go back and forth. Okay. Which can be helpful. There's overhead, so if you don't need it, you don't need it. We still don't have direct access to any element. We still have to search through, but we have a little more flexibility in how we go back and forth through the list. Okay. And it gives a sample code for that, which is worth looking at as well. Okay. And then the last thing we have here, down here eventually, it's going to be the idea of a circular linked list. So in a circular linked list, basically the last node points back to the first node. Okay. So there are times when this comes in handy in your problem solving. So it's certainly something that you can do. One thing that you have to keep track of is that you can't, everything that we've done so far, where we're going to look through until we get to the end of the linked list by looking for a null pointer, you can't do that, right? Because it's going to keep going forever and ever and ever. Okay. So because of that, you have to make some changes in how you're going to do that. You have to have another way to find out where things are. Okay. In this case, they're going to do a first node. Okay. So you know when you're back to the first node that you've made a full circle. Okay. So and they don't really design it here. In fact, that's going to be one of the problems this week is to design this circular linked list based on what we've done already. So I think it's an important exercise, but that's the idea. That's the problem we have. So when you're printing, when you're searching, whatever it is that you're doing, you're not able to just stop by looking for the last node. In a circular list, there is no last node. Okay, it just keeps going round and round. Okay. So hopefully that makes sense. Read through this chapter, get those linked list, the ADT, so linked list type, ordered linked list, get the code copied over and working, and also the double linked list, and then the circular linked list. You're going to create that on your own based on the others that you've done. Okay, all that will be on the problem set for this week. So that finishes the linked list. So again, linked lists are a very important data type. To reiterate, what we like about them is that they're memory efficient and that they grow in size gracefully. They use all the memory of the system and you can keep adding up to it. You never have to think, how many am I going to need? Okay, so that there's value to that. The other thing that's either a pro or a con is the linearity of a linked list, that you're going to go in order. There's no way to get from the first item to the seventh item without going through the second, the third, the fourth, the fifth, and the sixth. So having that order in some ways is helpful for certain problems in that we don't have to worry about if people are trying to go in the correct order. There's no choice in a linked list but to go in the correct order. But if you find that you're often needing to find the 100th item or the 45th item or whatever, then a linked list may not be what you need. You may be better served by something like an array or a vector where you can get directly where you want. Okay. So where we're heading from here, we're going to talk about some other data structures. I think stacks and queues are up next, but there may be something in between. I don't remember. I didn't look before I started this video. But anyway, that's kind of where we're headed. Okay. So um, again, these videos are meant to be an addition to the book, not in place of the book. So make sure you have the book, make sure that you're reading along and working through the exercises. So that's it for this video.